Alright, let's look at the homework 14.4, problem number 9. Alright, so what we want to do is use the differential to estimate the amount of material in a closed cylindrical can that is 30 centimeter high and 6 centimeter in diameter. If the material on top and the bottom is 0.2 centimeters thick, and the material on the side is 0.05 centimeter thick. Right, so let's do that. Right, thickness on top and bottom, it says that the 0.2 centimeter thick. So we know that the top one is 0.2 centimeters, and also the bottom one. So bottom one is 0.2 centimeters. And on the side here is 0.05 centimeters. All right, so let's do that. All right, since we are talking about a circular cylinder, so the volume of the cylinder V, so it's going to depend on the radius R and the height H. All right, then formula is going to be pi R squared times H. All right, then amount of metal. So we're looking to approximate. So we want the amount of metal is going to be, right? So we are looking at the volume of the, let's do the outside, right? So on the outside, the radius is going to be actually slightly more, right? Because the sidewall has a thickness of 0.05 centimeters, and the radius is 3 centimeters. And assuming that the 3 centimeter is the measurement on the inside, so you have to add on this thickness. So the measurement is going to be 3.05 radius. All right, the height is 30 centimeter, assuming that that's the measurement from the inside. You have to add on 0.2 centimeters on the bottom and also 0.2 centimeters on top. So this is centimeters. And so you have to add 0.4 centimeters. So you're going to have a 30.4 is the total height, right? Then we just have to subtract the inside volume because we just want the metal part. So we have a V of 3, 30. Right? So since this is a difference in V value, and so this is really exactly the same thing as delta V. All right. So since it's a delta V, it makes sense to, maybe I should write it down here. So this is equal to delta V. All right. So we can approximate this guy by the differential of this volume V. All right. So let's do that. So first we have to find the dV. So it's going to be dV is equal to partial V with respect to R times, and actually maybe I'm going to go ahead and plug it in. Number is 3 centimeter radius and the 30, right? Then multiply by dr plus partial derivative of V with respect to height H and evaluate it at the 3, 30, and then multiply by dH. Right? So we have to find these values. So let's find the partial derivative of R first. All right, partial derivative, with respect to R. So that's going to be simply 2 pi R H. All right. Then if you want to find, actually I'm going to go ahead and put it in here. Right, so this is going to be, if you plug in 3, 30, so we're going to plug in 3 here and the 30 here. So 3 times 30 is 90 and 2 pi. So it's going to be 180 pi, right? And times, right, dr. So dr is just the thickness of the wall, the metal. So it's going to be multiplied by 0.05, right? Then plus, we need to find the partial derivative with respect to h, and that will be simply pi r squared. Alright, so in this case, r is going to be 3, so it's going to be 9 pi is this guy. Then dh, so dh is going to be 0.4 times 0.4. Right? So we just have to find this value. So this is going to be equal to, alright, so 180 times 0.05. So it's going to be 9 pi, and plus 9 pi times 0.4 is going to be 3.6 pi, right? So this is going to be equal to, let's see, 12.6 pi. Alright, so we have to round it to the 2 decimal places. So let's bring out a GeoGebra. Alright, so I got the GeoGebra out, and I'm going to just compute 9 pi. Actually, not the 9 pi. We already found that the 12.6 pi, and hit enter. Right, and we need 2 decimal places. That's all we need. So 39.58. All right, let's plug it in. So we got 39.58. All right, let's submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.